Hello and welcome back to Machine Learning. I'm Javita Christie, and in this video, we are going to do some problems related to multiple random variables. Let x be a discrete random variable with the following PMF, and you're given some PMF for x. Now the question here says that you are defining a new random variable y as y equal to x plus 1 whole square. And what you need to calculate is the range of y and also find the PMF of y. So let's take a look at this type of a question. Now in this type of a question, this is also, by the way, a multi-variable, a bivariate question. So we are going to solve this question now. And okay, so let's first try to find the range of y. So what I have to find is ry. And I've been told that y is equal to x plus 1 whole square. And what is the range of x? That is what I'm interested in first. So let's just put the range of x. So x is having range -2, -1, 0, 1, and 2. So this is the range of x. So now if I have to find the range of y, I have to calculate it by placing all these values of x inside. So let's say if x is -2, then what do I get? It will be -2 plus 1 whole square, and that's going to be 1 minus 2, which is -1. So that gives me a 1. Okay, and you can also be getting a 0 as well. Okay, so this is 1. What happens if I have -1? Then it's going to be a 0. If I have a 0, it's going to be 1 again. If I have 1, it's going to be 1 plus 1, 2, which is 4. And then 2 plus 1, 3, which is going to give me 9. And because it's a set, you do not need to keep values which are duplicate. So we remove the duplicate here, right here. Okay. And also I could sort of rewrite the range of y and just arrange everything in ascending order because it looks good. So I have 0, 1, 4, and 9, which are the values of y. And if you wanted to write this in the form of set notation, you could write it like this, that this is equal to y equal to x plus 1 whole square, where x belongs to Rx. Okay, so we now have the value of Ry. We want to calculate the probability of, the PMF of y. How do we do that? It's very simple, fairly simple actually. All you have to do is find the different probabilities of y. So let's first find of y being 0. When can y be 0? When x is actually equal to -1. So when x is -1, then y is 0. So this is actually the probability of x being -1. What is the probability of x being -1? It is 1 by 8. Okay. What about y equal to 1? This can happen when you have the probability of x equal to, I think it was -2. When we took a value of x as -2, we got a 1. And the next one we took was, let me see, x equal to 0. So for both the cases, we got the value of y as 1. So you just have to add the two probabilities from the table. So for -2, it is 1 by 4, you can see here. And for x equal to 0, it is 1 by 8. And you need to evaluate that. You will be getting 3 by 8. So that is what is the probability. And let's take a look at probability of getting y equal to the next value, which was 4. Remember the range of y, so this is 4. To get 4, you can you can get 4 when you have x equal to 1, which we calculated earlier. The probability of getting x equal to 1 is 1 by 4. So this is 1 by 4. And then for y equal to 9, this happened when we took x equal to 2. So probability of getting x equal to 2 is actually 1 by 4. So this is also 1 by 4. And how do you verify all your answers? You just add whatever you got. So let me just go back a bit and see. So I got 1 by 8, I got 3 by 8. So I can just add all this, 1 by 8 plus 3 by 8 plus 1 by 4 plus 1 by 4. And when I add all this, I essentially get 1. So if I'm getting 1, that means my answer must be correct. So this is one way to verify your answer. I hope you understood this question as well. And we can move on to the next question, which is, again, considering two different random variables, x and y, and you are this time given a joint PMF. So we are going to be using some exciting new formulas for this because it is having joint PMF, and there's also marginal PMF, which is also another exciting formula to use. So let's see how we can solve this. Okay. Now in this question, the first thing you have to do is find the probability. Remember that now here you're given two variables, x and y, and the probabilities of those together, which is the joint PMF. So this is not a separate PMF function for each, it is a joint one. So we are talking about x and y happening at the same time, and then what's the probability? So we are given that those things right here on the table on the right. And what we have to calculate first is the probability of x less than equal to 2 and y less than equal to 4. That's what we have to find out. So how can you do that? To calculate this, you actually have to find out when can this happen? Okay, when can x be less than equal to 2? When it is either 2 or 1. From the table you can see here, it can be either 2 or it can be 1. Okay, so we're just going to populate it and write down 1 and just leave some space for y. And okay, so let's say that x is 1. What can be the value of y which is less than equal to 4? Y can be less than equal to 4 if the value of y is either 2 or it is 4. Okay, so two possibilities. So let's just combine those. We can have 1 comma 2 plus we can have 1 comma 4. The other combination we can have is 2 comma 2. Another combination is 2 comma 4. Okay, so these are all the possibilities of x, y together. And then we just find those probabilities. So we have from the table that x equal to 1 and y equal to 2 is 1 by 12. So just put that there. X equal to 1 and y equal to 4 is actually 1 by 24. So put 1 by 24 plus 2 comma 2 is 1 by 6. So this is 1 by 6. 2 comma 4 is 1 by 12. So this is 1 by 12. And if you add all this, you will be getting 3 by 8. So that's the answer for this first question. Now for the next question, you have to find the marginal PMFs of x and y. So this is the question for finding marginal PMFs of x and y. Now how do we do that? We have a formula for that, which was given in one of my previous videos. It's okay if you haven't watched it because you can understand pretty much what the formula says. Okay, so what it basically says is you are given a joint PMF, which is given here. Okay, this is the joint PMF of x and y. But what you want is an individual PMF of x and y. And you can find it in this manner. I've already written the answer, and I'm just going to show you how that answer came. Okay, so let's say what are the different values x can take. So x can take the value 1, x can take the value 2 and 3. So that's what we are specifying here, x equal to 1, x equal to 2, and x equal to 3. Okay, now how do I find the individual probabilities? very simple. For Px of x equal to 1, it's very, you just add all these things. That's what the formula says, that you keep the same value of x, but change the values of y and add all of them. So what do you get? You can add 1 by 12 plus 1 by 24 plus 1 by 24. Okay, what does that make for you? It makes 1 by 12 plus this would be 2 by 24, which is actually 1 by 12. So 2 by 6 and, sorry, 2 by 12, which is actually 1 by 6. So that's how this 1 by 6 came here. Okay, what about the second one? So if you want to find out Px of 2, then you have to add all the things that are present here. 1 by 6, 1 by 12, 1 by 8. Okay, so 1 by 6, 1 by 12, plus 1 by 8. And if you add all that, you will definitely get 3 by 8, which I have mentioned here. So this is 3 by 8. And similarly, to get x equal to 3, I have to add 1 by 4, 1 by 8, and 1 by 12, and that gives me 11 by 24. You can verify. And we know that x can only be 1, 2, and 3. If it is anything other than that, then the probability is 0, because it cannot be. Okay, what about y? So to calculate y, PMF of y, let's say we want to calculate probability of y being 2. So I'm sure you guessed it by now, we will be using the second formula from here. And I'm sure you guessed it that now instead of the row, you're going to go for the column. So we are going to go for stuff like 1 by 12 plus 1 by 6 plus 1 by 4. And if you add all of those, you're going to get 1 by 2. And similarly, for y equal to 4, you just add 1 by 24 plus 1 by 12 plus 1 by 8. So basically all these values. And for y equal to 5, you just add all these values right here. So that's how you can find the individual PMFs, which are also known as the marginal PMFs of x and y. So I hope this was pretty much clear that this is your final answer for the PMFs of x and y. Now let's get back to our question. So our question was like this, and we already finished we finished the parts A and B of the question. Now we have to move to the part C. So let's get rid of that table which we just created. Okay, we don't want the joint PMFs anymore. We want to use the individual or marginal PMFs that we created. And I want to calculate the probability of y equal to 2 given that x is equal to 1. And this should be easy for me because I have all these marginal PMF values associated here. So let's calculate probability of y equal to 2 given x equal to 1. And to do that, we know that this is actually probability of y equal to 2, comma, x equal to 1, the joint probability, and then division of all of that with p of x equal to 1. So that's what we have to find out. Now, what is y equal to 2 and x equal to 1? So let's just go back to what we had previously. So we had, this is y equal to 2. This is x equal to 1. The probability, joint probability, is 1 by 12. So we can have our answer directly over there, that this is 1 by 12. Okay, and that's going to be divided by probability of x equal to 1, which from this table, I can specify that it is actually 1 by 6. So this is going to be 1 by 6. So it is 1 by 12. Let me just write it properly, 1 by 12 and 1 by 6, which will come to 1 by 2 if you evaluate it. So 1 by 2 is the answer for that. Okay. Now let's talk about the last question. So the last question is saying, are x and y independent? Okay. So the question is, are x and y independent variables? So let's just take a look at that. Okay. When can you say that two variables, x and y, are actually independent variables. So that means that x and y do not affect each other. Okay, if you can prove that x and y do not affect each other, then you can say they are independent. And to do that, suppose you write down p of x equal to xi and y equal to yj. If that is equal to p of xi into p of yj. Okay, if this is true for all values of x and y, then you can say that they are independent. Okay, so I'm just going to prove that it is not true, because when I take p of capital X equal to 2 and capital Y equal to 2, okay, from my previous table I can see that x equal to 2 and y equal to 2 is actually 1 by 6. Okay, I have 1 by 6 here. So this is actually equal to 1 by 6. But if I find p of x equal to 2 into p of y equal to 2, what does that give me? So from my table, I can say that x equal to 2 is actually 3 by 8, and y equal to 2 is 1 by 2. So 1 by 2, and that would be 3 by 8, 2s are 16. So this is going to be this. So we know that this value and this value, they are not equal, which means you can safely conclude that in this case, x and y are not independent. Okay. If we had to prove that they were independent, we would have had to calculate all the values and say that they are all equal. But to prove that they are not independent, you just have to find one thing that doesn't match, and we have this one thing that doesn't match. You can find the rest as well, just for fun. So this is the answer to my fourth question in this big question. So I hope you understood all this. If you have any questions, you can leave them in the comments and I'll get back to you. And I'll be back with the next video. So I'll see you there, and thank you for watching.